Welcome all. In this lecture, we will look into the details of electron beam machining process. Electron beam machining is one of the thermoelectric type non-traditional machining process. So here electrical energy is converted into thermal energy, and this thermal energy is used to remove the material from the workpiece surface. So here we use a stream of high velocity electrons to remove the material from the workpiece surface. So in case of EBM, initially what happens is that this high velocity electron beam is made to strike the workpiece surface. So we know that this beam of electrons is moving at a particular velocity, so which possesses a certain kinetic energy. So and this kinetic energy of the electrons gets converted into heat, so when it strikes the workpiece material. So what will happen is that these electrons bombard on the surface of the workpiece material on a very localized area. So because of this bombardment of these electrons, the kinetic energy gets converted into heat. So this generated heat on the workpiece surface is responsible for melting and vaporization of the workpiece material. So in case of electron beam machining, the material is removed by means of melting and vaporization. So mostly it will be of vaporization only. So if you look into the applications of electron beam machining, so it is mainly used to produce holes, or we can call it as drilling. So any shape of hole can be possible with EBM. So here in case of EBM, round holes are usually drilled in metals, ceramic as well as in plastics. So and we can also machine electrically conductive as well as non-conductive materials with electron beam machining. So here which is shown in the figure is the basic schematic of the electron beam machining setup. So here we have different elements. So we have two different chambers in case of EBM. So the first one is the beam chamber, that is the electron beam gun. So here this spot is the EBM gun and this spot is the machining chamber, so in which the workpiece is placed. So here we have the chamber, that is the gun, so from which the electron beam is made to strike onto the workpiece material. So we have different components inside the electron beam gun and as well as in the workpiece chamber or the machining chamber. So initially we will look into the details of electron beam gun. So the first component inside the electron beam gun, EBM gun, is the cathode or the filament. So we have already discussed about electron beam welding. So it is electron beam machining is also similar to electron beam welding. So all the components are similar, whereas the application is different. So in case of electron beam welding, so it is used to weld two different pieces. Here in case of EBM, it is used to machine, that is to remove the workpiece material. So here in case of EBM gun, so we have the cathode or the filament. So we have a tungsten filament, so from which the electrons are emitted. So the emission of electrons is by means of two methods. So one of which is thermionic type and the second one is field emission type. So here we are using a thermionic type emission. So what happens is that, so we supply a very high voltage current onto the cathode. So because of this supply of high voltage current, this cathode or the filament, mostly it will be of tungsten filament, gets heated up. That is, the temperature of the filament will be of very high, that is, it exceeds the work function. So work function is nothing but the energy that is necessary to release an electron from the particular material. So when it reaches or exceeds the work function of the particular material or the tungsten material, what will happen? This tungsten filament starts to release the electrons from its surface, that is, emission of electrons takes place from the cathode. So when the electrons gets emitted from the cathode, so since the filament is made cathode, it gets repelled from the cathode and we have an anode over here. So these emitted electrons gets attracted towards the primary anode. So because of this anode, these electrons gets accelerated, that is, the kinetic energy gets increased because of this primary anode. So these electrons move from the cathode to the anode and starts to enter into the machining chamber. And in between the anode and the workpiece material, we have different components. So the first component is the deflecting coil. sorry, it is the focusing coil. So here we have a focusing coil or a magnetic coil, which is used to converge the electron beam onto the workpiece surface. So the main purpose of the focusing coil is to converge this electron beam into the workpiece surface. You know, this electron beam starts to scatter into the gun chamber. So in order to avoid this scattering, a focusing coil is used. So scattering of these electrons are avoided by using this focusing coil. So focusing coil converges these electrons onto the workpiece surface. And the second one is the deflecting coil over here. So this is used to deflect the beam, that is the electron beam, onto the workpiece surface. That we can alter the position of this electron beam by using this deflection coil. So these are the some of the major components that are used in a EBM gun. So here you can see clearly the components that are used in the EBM gun. That is, the first component is the cathode or the filament. So mostly it will be of tungsten filament. And after the cathode, we have the anode over here. So here this is a field emission type. So here what happens is that the filament emits the electrons, and the anode is used to accelerate these electrons onto the workpiece material. So as well as we also have a positioning diaphragm. So here we use a positioning diaphragm to alter the diameter of this beam. That is, so an electron beam is nothing but a collection of electrons. That is, a large number of electrons will be present in the electron beam. So we can alter this diameter of this electron beam by using a positioning diaphragm. So this diaphragm consists of a hole. So we can replace or change the diaphragm, so which has different sizes. So by which the electron beam size can also be changed. That is, the diameter can be changed by changing the diaphragm. And then next to the diaphragm we have the magnetic focusing lens, so which is nothing but the focusing coil, so which is used to focus or converge this beam onto the workpiece surface. And finally we have the deflecting coil. So when the beam strikes onto the workpiece surface, that is when the electrons strikes onto the workpiece surface, what will happen? This kinetic energy of the electrons gets converted into heat. That is, workpiece gets heated. So this heat generation will be over a localized area only, so not throughout the workpiece surface. So it will be in a localized area, and because of the heat generated, material will be melted and evaporated, so by which the metal will be removed from the workpiece surface. So here you can see all of these beam generation and beam travel as well as the machining takes place in a vacuum environment. So this machining will not happen in a normal atmospheric environment. So a vacuum is needed to carry out machining in case of electron beam machining process. Now we will see the mechanism of material removal in case of electron beam machining. So initially when the beam strikes the workpiece surface, so what will happen is that it heats, melts and partially vaporizes the workpiece material. So some of the material gets melted and some of the material will get partially vaporized. So this vaporized material will be removed out of the measuring chamber by means of vacuum, and there will be certain molten material within the cavity. So this happens throughout the entire thickness of the workpiece material. So this will be followed throughout the entire thickness of the material thickness. So at the bottom of the material, that is at the bottom of the workpiece material, we have a organic backing material. So at the bottom we keep a organic backing material. So when the beam enters this backing material or strikes the backing material, what will happen is that it also melts and vaporizes this organic backing material. So this backing material will remove out of this hole at a very high pressure. So along with this vaporized backing material, some of the molten metal which was present in this cavity will also get removed out of this hole. So this is the main phenomenon by which material is removed in case of electron beam machining process. And we will look into the contact between this electron beam and the workpiece material. So we have different types of electrons scattering possible. That is, when the electron beam strikes onto the workpiece surface, so some of these electrons are absorbed into the workpiece material. So here we have the yellow region over here. So this is the layer into which these electron beams or the electrons gets absorbed into it, and some of these electrons are scattered away. So these electrons are called backscattered electrons. So this scattering takes place by the electrons that are present within the base material. So the electrons from the beam get scattered away from the workpiece surface. So those electrons are called as backscattered electrons. And we have the secondary electrons. So this is generated. So when these electrons strikes onto the workpiece material, and some of the electrons from the workpiece material get scattered away or gets emitted away. So those electrons are called as secondary electrons. So these backscattered electrons are nothing but the same electrons that strikes the workpiece material, but these secondary electrons are from the workpiece material. So these electrons from the beam strikes away some of the electrons from the base material onto the environment. So this becomes the secondary electrons, and we have the backscattered electrons, so which are nothing but the electrons that are present in the beam which get scattered away from the workpiece material. And some of the electrons will also get reflected. So we have some of the electrons which also gets reflected away from the workpiece surface. And when this beam hits this workpiece material, so what will happen is that there will be certain heat conduction, heat radiation, and there will be some X-rays generation, and we will have heat affected zone. So here in case of EBM, there is a heat affected zone. So it depends upon the beam power, that is the energy of the beam. When the energy of the beam is very high, then we will have larger heat affected zone. As well as we have transform layer. So here transform layer determines the any phase changes or microstructural change that is happening below the machined layer. So this is the main mechanism of material removal in case of electron beam machining process. Now we will look into the details of different elements that is present in the electron beam system. So already I have explained regarding the setup of the EBM machine. So we have very different elements like machining chamber and EBM gun. So in case if you look into the details of EBM gun, so we have various elements with respect to EBM system. So those are electron beam machining gun, power supply, and vacuum system and machining chamber. So we are adding one more element, that is nothing but the power supply. So if you look into EBM gun, so it operates in pulsed mode. That is, the beam generation is not continuous. That is, the electron beam will not be continuously striking onto the workpiece material, and the electron generation will be in pulsed mode. So the electron beam gun produces and focuses electron beam at predetermined location. So the location will be predetermined initially by means of computer control or programming, and this electron beam generation is by means of superheated cathode. So this is by means of the supply of very high voltage current. So this electron beam is nothing but electrons cloud. That is, these electron clouds consist of a large number of electrons present in it. So these electrons are repelled from the cathode and attracted by the anode. So here we have the cathode and there is an anode present over here. You know that electrons are negatively charged, so it gets repelled from the cathode, but it gets attracted by the anode. So because of this, so the kinetic energy of the electrons will get increased. So it depends upon the voltage that is being supplied onto the anode. And we have a magnetic lens, so which is used to converge the electron beam onto the workpiece. And stray electrons are removed to reduce the diameter of the beam. So here stray electrons, that is the electrons that are being diffracted away, not diffracted, those electrons which are not within the beam can be removed using the diaphragm, so by which the diameter of the beam can be reduced. So next we will see about the power supply. So the power supply can generate voltage up to 150 kilovolt. So the maximum power will be around 12 kilowatts. and we have seen the beam generation is in pulsed mode. So the pulse energy will be around 120 joules per pulse for a single pulse. So the energy will be around 120 joules, and we have controlled the process variables using a computer or a microcontroller. So controlling the EBM will be easy, so because of this computer control. And if the electron beam has higher power density, then melting and vaporization is possible. So mostly the melting will be, or the material removal takes place by means of vaporization, because you know the entire chamber is present inside a vacuum. So whatever the material that is removed gets vaporized, and it gets removed out of the chamber from the vacuum pump. And final element is the vacuum system and machining chamber. So here beam generation and travel. So the here beam is nothing but the electron beam. So electron beam is generated over here, and it is traveling through the electron beam gun, so which happens in a vacuum. So it is not happening in a normal atmospheric environment, so it is happening in vacuum. So this is to avoid oxidation of the filament. So you know, in order to avoid the oxidation of the tungsten filament, so we are using a vacuum. So if it gets oxidized, what will happen? It reduces the electron emitting capability. Also, in order to avoid the collision of electrons and air molecules, so what will happen when these electrons collide with the air molecules? The kinetic energy of these electrons may get reduced. So because of that, the heat generation will be lesser. So in order to avoid that, so we are using a vacuum. And finally, the vacuum can be varied between 10 to the power minus 5 to 10 to the power minus 10 to the power minus 4 to 10 to the power minus 5 torr. And now we will see about some of the process parameters. So the first one is the beam current. We know that the electron beam gun is generated in pulse. So for each pulse, we can give a different current. A current can be given. So this beam current will be varied between 100 microampere to 1 ampere. So it governs the energy per pulse. That is, if the current is higher, then the energy per pulse will be higher. So higher value of beam current leads to higher material removal rates. Similarly, deeper penetration. And next is the pulse duration. That is the time for which the pulse is active. So the pulse duration can be varied between 50 microsecond to 10 millisecond. So longer is the duration, the hole will be wider and deeper. And it can also affect HAS. That is, if the pulse duration is higher, then obviously HAS will be more. Similarly, recast layer. So here recast layer is nothing but a layer that is formed because of the solidification of the molten material. So you know that because of the electron beam, so the material gets melted. Some of the molten metal will get solidified onto the surface of the hole. So this becomes the recast layer. So because of higher pulse duration, it can affect the recast layer thickness also. So this will be less than or equal to 0.025 mm. And the next thing is the lens current. So here you can, this lens is nothing but the magnetic focusing lens. So it determines the working distance. So working distance is nothing but the distance between the lens and the workpiece surface. So if we vary the current for this magnetic lens, then this working distance can be varied. And beam size. So beam size can also be varied by varying the current which is applied to the magnetic lens. And finally, the beam deflecting signals. So here beam deflecting signals is the nothing but the signal which is given to the deflection coil. So here the hole shape. So if we want to machine a circular hole, then the focal point will be on the top surface. So here you can see the focusing point of this beam is on the top surface. So if we want to produce a straight hole, but if we want to machine holes which has shape other than the circular one, so if we want to make a tapered hole, then this focal point or the focusing point will be at the bottom or below the top surface. So we can vary this focusing point by varying this beam deflecting signals. Next is the material removal rate. So we can calculate the MRR in case of EBM using this formula, eta times P by W, or P over W. So here eta is the cutting efficiency and P is the power per pulse in case of joule per second, and W is the specific energy. So this is energy per unit area. So this specific energy can be calculated using this formula. So here Cp is the specific heat of the material, Tm is the melting temperature of the workpiece, Ti is the initial temperature of the workpiece material, and Tb is the boiling temperature of the workpiece, and Hf is the latent heat of fusion, and Hv is latent heat of vaporization of the workpiece material. So by which we can calculate the material removal rate. And finally, if we look into the applications of electron beam machining, so here's the industries that are using this machining process are like aerospace, insulation, food processing, and chemical industries, as well as in clothing industries. So here mostly EBM is used to generate number of holes, that is a numerous holes can be easily made with electron beam machining process. That is, the numbers vary between hundreds to thousands. So this can be made or drilled in a workpiece, so which is very difficult to machine. So this machining can these holes may have like complex shapes, and the material will be like difficult to machine. Also, it is easy to make perforation in any metals, ceramics, or plastics. So we will look some of the examples of EBM. So here in case of turbine engine, combustor dome, we are using EBM. So here this is the part which has a number of holes which is drilled onto it. So this part can be made using an electron beam machining setup. And next is a fiber spinning head. So here you can see this is a fiber spinning head. So here also you can see there are now a number of holes present in it. So this can be machined using an electron beam machining. And holes in filters and screen in case of food industries. So in case of filters, so there will be a number of numerous holes present in it. Similarly in case of screens also. So this can be made using electron beam machining process. And cooling holes in turbine blades, so this is possible with EBM. And finally metering holes in injection needles or injector nozzles. So these are some of the examples of or applications of electron beam machining process. So in the next class we will look into the details of laser beam machining process. Thank you.